Virtual device context, VDC, virtual device context. Now from the word we can understand that it's something related to virtualization. It's something related to virtualization on Nexus device. Now what all we are going to discuss. First of all, we need to identify why we need VDC. What is the advantage of having VDC? And next is the architecture of VDC. Next is how to configure VDC and how to configure VDC resource template, which is also a part of our exam, which is a resource template, where we say how many number of VLANs, maximum, minimum. Hope you remember that question. The minimum number of VLANs, maximum number of VLANs, minimum number of VRFs, maximum number of VRFs. Likewise, we can also say how many number of line of IPv4 routes you are allowing, like in a fib table. How many route entries can be seen? Minimum, maximum. IPv6 route, multicast route, unicast route, IPv4 route. So all these things can be done through resource template. All that I spoke just now, they are part of exam. And then we will also see some advancement that has been done from 6.1 version of Nexus OS. Whereas we already saw in CCNA, number of VDCs can be up to 8. It is not in every iOS. It is from 6.1, which has got SOUP, engine SOUP 2 and SOUP 2E. Right. So those things we will be discussing here. Now, why we need VDC? The simple reason is I want more device. In aggregation layer or in core layer, I want more device. So when I need more device, I can make use of VDC so that I can buy less number of device and I can save some money. Not only that, management is very easy because we take care of only one device. It's not multiple device. Energy consumption, space consumption, cooling effect consumption, all those things are less. So for all this reason, we try to virtualize the physical device that we already have instead of going for a new device. So VDC provides complete isolation in administrative as well as operational between VDCs. Meaning, if I have 3 VDCs, all 3 VDCs are separate. There is no internal connection between these VDCs to communicate, and they are 100% as equal as the physical separate physical device. So VDC provides administrative as well as operational separation inside a single switch. That's what this diagram, this picture explains us. Here we see there are 3 zones needed. There are 3 departments: sales, production and engineering. So what we do is we create 3 VDCs. And these 3 VDCs are totally different. That's what the coloring tells us. Now there is also one more VDC called default VDC. This default VDC is the one which manages the other VDCs. So now from this diagram itself we can understand that default VDCs are not really okay to use as we use the non-default VDC. Non-default VDCs can be used for various zones, but it is really recommended to have default VDC only for the sake of management. So VDCs are device context, meaning we make a single physical device to work as multiple virtual device. That's what a VDC is. So 7000 Nexus 7000 series supports VDC, and we see that we can do 3+1 VDC by default in older iOS, before 6.1, and with normal SOUP engines. Default VDC is always recommended to be a management VDC. Now from here only we create VDCs. We allocate resource to the VDCs. From default VDC only we create all other VDCs. Alright, so though we got VDCs today, we already have VLANs and VRFs doing a similar kind of virtualization. But the difference is, in VLANs we got virtual LANs, virtual layer 2 separation, meaning data plane separation. In VRF what we get is a layer 3 separation. We got separate control plane, we got separate routing table. Now this is one step more. What is that? We got management separation. Not just data or control plane. This is one step more. Even the management plane is separated, meaning we got separate running configuration. The iOS instant is copied for each VDC. You will have a separate running configuration for each VDC. So this is more isolation in virtualization world. So the entire box is like virtualized. We got management plane, control plane and data plane. All three are virtualized here. So VDC provides not only just data plane separation and control plane, it also provides management, which it can be called as resource and operational separation. Both resource as well as operation separation here. Resource is also separated, whereas in VRF and VLANs they are not fully separated. If you talk about VLANs, we put multiple interfaces in different VLAN. In that way we can say, yeah, resource is separated, but still the control plane, those things are common. If you talk about VRF, the management plane is common for all. But here in VDC we have real isolation, the complete isolation in all three planes: data plane, management plane and control plane. So because we have this, there is an advantage. What is that? If one of the VDC is malfunctioning, we can easily isolate, we can easily manage. Why? It's not going to bring down the entire device. It's going to bring down that particular VDC alone, not the entire Nexus box. So other VDCs are happily working, only this VDC undergoes some fault. Say for example, if VLAN, or let's say if STP fails, or let's say OSPF fails. If OSPF fails in one VDC, that's not going to affect the OSPF on the other VDCs. So routing is not disturbed in other VDCs. So we got management plane separation. That's the advantage. So here, when we talk about VDC, there are three different ways it can be deployed. One is dual core. The other one is let's simply make it simple. VDC deployment on core level, on aggregation level, and in aggregation level based on service. Three different ways in which the deployment can be done. Now if you talk about core level deployment, VDC is needed only when we are going for more than one core, which is dual core. Why we need that? If I have two data centers to be merged, I need two sets of Nexus device. Why I need a set of device? For redundancy. If one Nexus device undergoes some maintenance, the other Nexus core device can back up. So for each data center I need two Nexus box in core, one for active and another for standby. Now if I add one more data center to my core, then I need other two Nexus boxes. Now instead of buying other two Nexus box, what we can do, we can create one VDC on the existing boxes and have the other data center. So that's what that's what we see here. it's really cost effective. This is one physical box, 2 VDC. This VDC is working for this data center. This VDC is working for this data center. When this undergoes some maintenance, this is going to act as a backup. When this undergoes some maintenance, this is going to act as a backup. So this is VDC deployment in dual core level. Now in the aggregation level, core is already there. Now in the aggregation level, where we have multiple access layer, because of our business reason, there are two different access layers, and for this access layer I want to give a dedicated box, a dedicated aggregation layer, and for this I want to have a dedicated aggregation layer. Now in this case also I can give one VDC for green, another VDC for red. So solves the problem. I don't need to buy 4 boxes, I just buy 2 boxes, one for active, the other for standby in aggregation. Now there is another example where service insertion, meaning I want 2 Nexus box, one doing some X job and giving the output, and the other takes that and process it. So I need 2 boxes. So what I do partitioning, I do VDC. So input comes from access layer to this VDC, and the output comes out and goes to the other VDC and getting processed here before it goes to the core, because of some service demand. Because of some service demand, I need 2 Nexus box. Totally 4 I want in the aggregation layer. One for this and another for this. I no need to buy really 4. With the help of these 2 boxes I can manage by creating VDCs. So these are the 3 different deployment scenario of VDC in core and aggregation layer. Now when we talk about VDC architecture, we got the base kernel, which is common for all VDC, on top of which VDCs are created. Now each VDC has got its own layer 2 protocol, layer 3 protocols. These are all layer 2 protocols: trunk protocol, ether channel, multicast, CTS, UDLD, which is for the loop prevention, VLAN manager, OSPF, BGP, SNMP, VRP. All these are layer 3 protocols. So separate control plane, separate data plane, and we got separate IPv4 protocol stack. If you have IPv6, then separate IPv6 and layer 2 protocols. So all are separate for each VDC: layer 3, layer 2, and management. Default VDCs are supported in Cisco Nexus 7000 only. So up to 4 VDCs we can have per switch, and it is not all 4 going to serve us. One default VDC is recommended to dedicate it only for the management purpose, to manage the other VDCs, to create, to delete, or to manage, means to allocate resource to the other VDCs. Resource like processor, resource like interfaces, ports, VLANs, VRFs, and so on. So it is 3+1. Non-default VDCs are strictly separated, meaning default VDC can talk to red VDC, which is non-default, green, yellow. But red and green cannot talk, green and yellow cannot talk without external connection. Internally they cannot talk. Externally you can connect a cable from one of the port on red to one of the port on green. Then it is possible as you talk between 2 different switches, physical switches. but internally there is no connection. Non-default VDCs are strictly separated. Now this non-default concept of a default, non-default, no, we don't call default VDC. VDC1 is default VDC. From 6.1 version onwards, we call it as admin VDC, especially on SOUP 2 and SOUP 2 engine. If we will definitely have this iOS. Then when we call the default VDCs as admin VDC, so it's more meaningful than calling it as default VDC. The reason why we call it as admin VDC, this does administration job. It controls all other VDCs. It allocates resources and so on. As we already discussed, there is no internal communication between VDCs. So there is total layer 2 and layer 3 separation. Layer 2, layer 3 separation. So VLAN number that you use in one VDC can be used in other VDCs. That won't cause any conflict. The reuse of VRF name and VLAN names are allowed. In case if I want to communicate between one member of this VLAN to the other member of this VLAN, all I need to do is I need to connect one cable here, another physical cable externally to do the connection. So external connections are necessary to forward the traffic between the VDCs if required. As we already saw, the isolation of fault domain. Like if some routing protocol fails on one VDC, it's not going to affect the other VDC because there is isolation between VDCs. Now, next is there are three different types of resource. Three types of resource that we have in VDC. There are a few, yes.
Sir, do we have any facility in VDC where we can move one VDC profile to another VDC? Three VDCs, I'm including VDC 4. So I want to move whatever the configuration has been done to VDC 3 to VDC 4 because I want to delete that VDC 3 because maybe it got crashed or something for some reason. Do we have such kind of thing like what we discussed for 1000 VP motion?
No, we don't have here. We do not have that type of facility here. All what you can do is we can copy through TFTP or through something. We can copy externally and then copy it back to the new VDC. And that's what we can do. That's not possible internally. There is no vMotion kind of thing here. It was a good question. Now VDC there are three different types of resource sharing, meaning there are some resources which are globally shared, example NTP, control plane policing, configuration, span, the switch name. The default switch name is common for every VDC. So if I have VDC 2, it will have default name and then that number 2. So switch name is common, boot image is common, NTP time that you have for default VDC is same for all other VDCs, and NTP control plane policing like rate limit, all those stuff, quality of service, all those stuffs are common for all VDC. Those type of common features we call it as global resource. Those type of common resource. There are some resource called shared resource. Shared resource. Example, out of band Ethernet management. What is this out of band Ethernet management? See, you have one management interface, MGMT0. Now this MGMT0 can be used to access VDC1, VDC2, VDC3, VDC4. Really? Yes. But we saw that VDCs are totally isolated. How can one interface take you to all four? That is what called as out of band. It is not in band. It is not subjected to a VDC. It is out of band. Actually, what really happens is there is a logical switch created out of band, and a connection is made between these VDCs logically, not physically. So what we have is, we have this management interface MGMT0. So someone who connects to this management port can do some sort of management job telnetting to VDC 1, 2, 3, 4 just by using this one single port. Now, will these VDCs have different IP address or same IP address? Will this VDC have different IP address or same IP address? You might have already guessed. You see, we got a layer 2 switch. I said it's a logical switch. So we got different IP address but same subnet. It's a switch. These are all like layer 2 device now. So they all must be in same subnet, like 10.0.0.10, 20, 10.0.0.40, but they all belong to same subnet. This is what shared resource example. This one single port is being shared with all VDCs. Now this one we understand very well, dedicated resource. So whatever is given for a VDC cannot be controlled by other VDCs, cannot be utilized by other VDCs. They are dedicated resource. Example, physical switchboard, VLANs that you create, VRF that we have in a VDC cannot be shared with other VDCs. Other VDCs can have same name, but they are not the same. So three different types of resource that we have in Nexus: global, shared, dedicated. Now there is something called resource template. This resource template is like peer group that we have in BGP. You know, if we have multiple IBGP neighbors, instead of saying A is my neighbor, remote AS20, B is my neighbor, remote AS20, C is my neighbor, remote AS20, with this A, B, C and D, update source, loopback 0. Instead of repeatedly saying same thing with multiple neighbors, we can create a template and call the template. Likewise, we can create some templates with some common resource, and then we can call the template under multiple VDCs. So templates can be made so that those templates can be called under VDCs. So instead of me saying to every VDC, VDC red, you take minimum of 10 VLANs, maximum of 20 VLAN. Green VDC, you take minimum of 10 VLAN, maximum of 20 VLAN. Instead of repeatedly saying the same thing for multiple VDCs, we can create a template and we call the template for each VDC, so that, you know, single time processing, there is some uniform consistency in configuration for all non-default VDCs. Like this, for non-default VDC, I want to give a maximum and minimum of 8 MBps memory for IPv4 unicast traffic, and again 8 MBps for IPv4 multicast traffic, 4 MBps for IPv6 unicast traffic, 2 MBps. So this is what I want to do for all non-default VDCs. So instead of going and repeatedly saying these many lines in each VDC, we put this thing in a VDC in a VDC template, and let's call the template as ABCD and call that ABCD under each VDC. This is exam sensitive portion. This is also there in exam. You might have seen already in section 1. This has been created according to what question says and called under each VDC. So we should not assume something and do exam. This is what actually we do. We create a template according to what the question says for non-default VDCs, and we call the template. Next is interface allocation to VDC. Now when we allocate interface, when we assign some interface to the VDCs, we need to be very careful about the IO module. Since these modules are different from this module. These modules are different from the other modules. In what way they are different? These modules, they are grouped as 4 ports each. Even in CCNA we saw this. And this IO module, if you have, then ports are grouped 2. And if you have any of this module, no need to worry about port group. When I say port group, don't go to that port group. Grouping of port, the physical grouping, physical port grouping. Now if you take any of this, what can be done is, if you want to have 4 interface, you can take this top 4 interface, 1 2 3 4. You cannot take something like this. You cannot take like this. Why? The below 4 belongs to another group. This is one group, this is another group. So if I want 8 ports in a VDC, then I can take all 4, no problem. But if I want only 4 port, I should take only this. Let's say this is Ethernet 10, 11, 12, 13. Sorry, 10, 12, 13 is below, 14, 16. So I can group 10, 12, 14 and 16 for one VDC, and 11, 13 all evens for one, all odd for other one. So this thing need to be considered. When we have this module, then it is grouped like this, 2. I cannot take this top 2. I can take only these 2. So need to be careful in exam what module we have. We need to check accordingly. We need to think about the port allocation. Now here, if you have any of this module, no worries. Any port can be assigned to any VDCs. See, we have multiple colors here, red, yellow, blue. You don't see something like that here. Whatever the top is, the below one is also the same color. Green, green, yellow, yellow. Here all the upper one is same color, all the below one is same color. 4 groups. So this need to be considered. Right. Now about learning MAC address. See, we have multiple IO modules. In 7000, if you take 7010 series Nexus box, we have 10 modules. In that it is actually 8 plus 2 soup engines and 8 modules. If you have 8 IO modules, now we may have few interface from here and few interface from here for VDC red VDC, and a few interface from here. Let me change the color. Few interface from here, few interface from here, and few interface from here for blue VDC. Blue VDC. Now how the MAC address learning happens is, when I have a PC, let's say the MAC address is A, The MAC address of A will be learnt on this module's MAC address and this module's MAC address, not on this, because I don't have any member of red in this module. You remember VLAN pruning in layer 2 switching? Same like that. If there is no VDC member there, then the MAC address coming from that VDC will not be seen there. So this is how the MAC address learning happens when we have VDCs and when we don't have VDCs in IO modules. Right. Now this talks about the resource. For each module there is some resource allocation, the maximum resource 128 kilobits. For what? For forwarding information base, or in module number 1. In module number 1, for ACL, this much of kilobits is allocated, dedicated. That's the maximum you can go. And with the help of 128 kilobits, how many lines of IPv4 you can have? 128 thousands of fib entries. That's the maximum you can go. IPv6, this is the max. ACL, this is the max. So with this memory, this is what we can get as maximum. Now why we see this? It's coming in the next slide. When we allocate resource, we need to be very careful. See, we saw that for fib, what is the maximum? What is the maximum size? For fib, 128 kilobit is the maximum. 128 kilobit is the maximum size for fib. Now, how can I have this one and this one? 128 is the maximum. If you add these two, 100 plus 90 is what needed. If I want to share IO module for VLAN 10 and VLAN 30, IO module needs 190, but what is there in a particular IO module is maximum 128. 190 is too much, more than what is already there in the IO module. So that's why here in the example it is explained, you can group VDC 10 and VDC 30. These two can share. So this module and this module can be shared. I'm sorry, I'm saying opposite. This and this modules can be shared because they got 10 and 100. Likewise here, even here also, ACL 40 plus 10, 60. What's the maximum you got? 64. But we cannot do what? 50 and 40. That is what here explained. Combining VDC 10 and 20 or 10 and 20 or VDC 20 and 30. Okay, these two also can be combined. 90 plus 10 is 100, which is less than the maximum. Right, so resources, when we do allocation, we need to be careful about the maximum resource that is available in a module. Before we share the ports from one module and the other module, we need to be aware of the availability and the requirement. Based on that, we need to allocate. So this example shows that VDC 10 is using this much of memory out of 128, so it is under control, and this much of ACL, and the blue one is using only this much of routing input, like 10 plus 90, something like that, less than 128, not reaching up to the brim. So this is not overloaded. This is nice. So that is what resource allocation. Now we will see the practical, we'll see the configuration part of this in few minutes. Before that, we have few additional features that has been added in 6.1 version onwards. Let's see that. So we don't call anymore the default VLAN as default VLAN, VDC1 as default, sorry, not VLAN, default VDC, VDC1 as default VDC. We call it as admin VDC, and it's purely for administration purpose, for configuring control plane policing, in service software upgradation, or EPLD. We'll see that, and to create VDCs, to suspend a VDC which is already running if you don't want to delete, to allocate some interface. All right, these are the management stuff, like Cisco Gold, Cisco, and then debug we got, and then we got tech support. To do those things, we need admin VDC for quality of service, for port channel, for load balancing. All this can be done. So when we do that, when we have a dedicated VDC for management, there is more improved security, and even these things are simplified configuration for data plane, because we got the control plane policing on the default VDC. All right, and so on. Now initially only available, okay, this feature is available only on supervisor 2 or 2E engine, and for doing one VDC, admin VDC, and one data VDC, there is no advanced license required. If you want to go more than 1+1, then if you want more than 1+1, then we need to have some licensing. But still we can use that free license that is available for, I think, 120 days. After that, those VDCs will be removed. So all control plane policing configuration is performed in admin VDC, which is, what is control plane policing? The rate limits that we set for the interfaces. Module control is performed in admin VDC. Module control means turning off the module, power off. If you want to power off a particular VDC or particular module, out of service is the command. It shuts down the particular module. So those things are done from VDC, admin VDC, the default VDC. Licensing management is performed in admin VDC, and what all cannot be done in default VDC or admin VDC is enabling a routing protocol or layer 2 protocol for a particular VDC is not possible. So these are the features that is available in the default VDC. Feature, put question mark. You don't have OSPF here. You don't have anything related to STP or any layer 3 ether channel, or sorry, layer 2 ether channel. We don't see that. We see only the management kind of features available here. Only this, all management related. Shared one. Right. So that's the limitation from admin VDC. We cannot do layer 3, layer 2 configuration on behalf of some other VDCs. We cannot do on behalf of some other VDCs in this VDC. So if you want to assign an IP address, we need to go to that particular VDC and assign. We cannot do that from the admin VDC. From admin VDC, all that you can do is allocate some resource for non-VDCs, non-default VDCs or non-admin VDCs. So now CPU, by default, if you see the CPUs are equally shared between VDCs. By default, the CPU, the processor, is equally shared among the VDCs. But we can use the priority and say this VDC I give more priority. Now, bigger the number, lower the priority, lower the number, more the priority. That's how it works. The more VDC configuration, the lower the overall percentage per VDC. So if I keep the priority lower, I get more CPU prioritization. So by default it is equal among all VDC. If you want to control the process, if you want to allocate more process for a particular VDC, that is also possible, and that is available from 2 and 2E super engines. Now configuring VDC is straightforward. If you know about security, you are working in security ASA, so same like that. As you create multiple contexts, here also we can create multiple VDCs. Now before we get into configuration of VDC, let's talk about some role-based access control. So by default there are 4 different roles. We got admin, network admin role, network operator. The first user that you create on a admin VDC or default VDC is called as network admin. Now this network admin has got full control over not only the default VDC, with all other VDCs. So he has got full control over the default VDC as well as the non-default VDC. So he can create any VDCs, he can delete VDCs, he can change VDC. He has got control over the default VDC. If he has got control over the default VDC, he can do all this job. He can also get into the other VDC and have full control over the other VDC. That's what this line explains. The network admin, when he gets into the non-default VDC, he gets the admin right of that particular non-default VDC. There is another role called network operator. This is the second user that you create, and he has got only read-only write. He has got only read-only writes. Now this can be changed. It is not like always first user is network admin. If you want to change it, you can change the role later. And what about this non-default VDC? On non-default VDC, the first user that I create is a VDC admin. VDC admin has got full control over that particular specific VDC. He has got no rights to see anything on the other VDC, not even read only. He has no control over any. He cannot do anything with the other VDCs or the default VDCs, other VDCs or default VDC. So likewise, VDC operator is the one who has got only read only write, and these two guys have no scope with other VDC. They are limited to that particular VDC alone. So when a network operator goes to non-default VDC, he gets read only write on the non-default VDC as well. So that's the power of the network admin and network operator. Whichever the VDC they get in, they get the corresponding role. Now VDC configuration, now we can create multiple VDCs if we have license. If we don't, at least by using the grace period we can go and test it. But what will happen is when the day expires, all VDCs will be gone and all the resources will be given back to the default VDC. So as we all know, we need to create or delete or modify any VDC, all that we need is a network admin role. By using network operator, we cannot do anything, we can just monitor. So VDC interface or the physical port that we assign to VDCs, and this is configured from the default VDC only. But giving an IP address, all those things can be configured, not can be, should be configured only by getting inside the VDC. Allocating an interface is done from the default VDC. Assigning IP address, all those layer 2, layer 3 job can be done only by getting inside the VDC. Now if I want to remove a VDC, I can remove it by coming back to the default VDC and say no VDC red. It removes the red VDC, and all the resource that is under red will be given back to the default VDC. Now this is the example. By using the command VDC red, I create VDC, but I am not inside VDC. I just create VDC, and whatever the resource that I want to allocate, I can allocate here. And if I want to remove a VDC from the default VDC, this is the default VDC, this is the default VDC, I can remove by putting no. It will ask for the confirmation. When we say yes, all the resource will be given back to default VDC after removing the VDC. Now this is one. Next is how to allocate resource. There are two ways. One, straight away you go and say allocate interface Ethernet 2/1, and when we say that, it will ask for confirmation. Hey, are you really want to do that? Because if you have already some configuration under this interface, all will be removed when it is assigned to this one. Is it okay? When we say yes, it assigns. If you want to assign a particular interface, this is how we do. If you want to assign consecutive interface, we say this, port number 1 to 8. Or if you have non-consecutive interfaces, we can put comma. We can say that, like a range command in switching. Now this is one way of allocating resource, straightforward, going under VDC and giving, not going inside VDC, going under VDC. So if you want to go inside VDC, this is the command. We use the switch to command, switch to VDC red, it takes me to the red VDC. This is different, this is different. So if I want to come back to the default VDC, I say switch back, it brings me to the default VDC. Right. So next is when I type show VDC in the default VDC, I can see the number of VDCs and the names and their state and then the MAC addresses. If I want to, if I say detail, I can see even the other information like MAC address is already okay. High availability policy. So if I have dual supervisor engine, what is the high availability policy? If I have single supervisor engine, what is the high availability policy? So those things also can be seen if I say detail. Now if I go inside a VDC, if I go under a VDC, if I switch into a VDC and type the same command, I will not see all the VDCs. I'll see only the VDC on which I am right now. I'm right now under the red VDC, so I see only red VDC information. But if I do the same command under the default VDC, I see all the VDCs including default VDC. Now if I want to see the interface allocation for the VDC, I type this command show VDC membership. It will show all the VDC name and the interface that are allocated. Now if I want to see the resource allocation, I type in this command show VDC resource. It shows port channel, the minimum, the maximum, monitor session, the minimum, the maximum. If you want to say detail, you can say detail. For port channel, you see the information. For monitor session, you see the information. It will be more granular. So this talks about the template. See, we create a template called VDC red, and we limit the resource. Sorry. This is not the template. This is limiting the resource. We go under the yes. This is also part of exam. We go under VDC. We say this can use minimum of 32 VLAN, maximum of 4094. Likewise, we can do for VRF, we can do for port channeling, we can do for unicast. This is for unicast, IPv4 routing, the maximum number of entry memories. So which one? This one. These are all standards. This is not standard. No. Those things are not standard. That was like, it was, you're right, but that is not this small number. That was a double digit number. In memory it was some double digit number. For routing alone we were having 128. This is maximum minimum. This is giving for one particular VDC. I cannot give the entire maximum allowed memory only for this red VDC. We also need for other VDC. So whatever is needed here, we only give that much. So we can also create template and do the same. We can say VDC resource template, given name, and then we can say limit resource, VLAN minimum is 32, maximum is 256, and then VRF minimum is 32, maximum is 64, and then we can call this particular template under a VDC. You remember we did the revision, the question paper section 1.4 or something talks about this template assigning to VDCs, creating template and assigning to VDC. So after creating templates, we can say this command show VDC resource template production. We can see the VLAN minimum 32, maximum 256, VRF minimum 32, maximum 64. So that is about resource template. Next is out of band management, which we already discussed. If you want to manage VDCs, we can do telnet, we can do SSH, we can take syslog using SMTP, we can do many things, but to do management we need some interface. So that can be an in-band or out of band. If you talk about in-band, we got on logical switch connecting to multiple VDCs. This is one physical device, but internally we have a logical switch. This is connected to this. This is so same subnet but different IP address. Which we called as out of band. So what is in band? We don't have out of band. We got a dedicated interface for each VDCs for management, for radius server, for syslog, for telnet. So we got dedicated interface for services, for management services, and only through that we talk to the VDCs. So here the IP address and subnet mask will be different because it is in band. Now when we talk about high availability, there are 3 or 4 different types of high availability we can say, meaning when something goes wrong with VDC, when something goes wrong, like some process getting crashed in a VDC, what action need to be taken? There are 3-4 options. You see, if I have single supervisor engine, can I do switch over? No, I already got only one supervisor engine. How can I switch over to another supervisor if I don't have? So all that I can do is I can just restart that VDC. or I can bring out that VDC. If I have dual supervisor engine, I can switch over, or I can reload. If I have only single supervisor engine, restart, reload. There is some difference between restart and reload. Reloading is like loading to loading again. Restarting is like restarting with the default configuration, not with the latest configuration. One second, let me give you a very clear definition. Okay, restart. Restart deletes the VDC. Restart deletes the VDC and recreates it by using the startup configuration. Okay. So restarting is like, because something went crashed, when we say restart, it deletes the, that's what I was also telling. It deletes whatever that was configured and restarts with the default. It deletes the VDC and recreates it by using the setup configuration. Right. Whereas reloading is just reloading the supervisor module. Okay, so this reload and restart is more focused only when we have single supervisor engines. Okay, so this is how it will look like after configuration, and this is how we do the configuration. Now here we say for red VDC, high availability policy is this: when I have dual supervisor engine, when something goes wrong with the operation process inside the red VDC, I'll restart. In case if one of the supervisor engine is taken out from my Nexus machine, if there is only one supervisor engine, there also I restart. It is not really a good example. When I have dual, I can say switch over. When I have single, restart. That will be more meaningful. Here they're just showing the command how to configure. High availability, dual supervisor engine, bring down. Single supervisor again, bring down. Not really good example. So as we already said, dual supervisor engine, bring down. Single supervisor engine, you can bring down or you can reload or restart. Something like that. So after that we can go and verify. Show VDC detail. We can see the policy. If I have single supervisor engine, this is what I need to do. When something goes wrong with the particular VDC's process. If I have dual supervisor engine, this is what I need to do. Now to save the configuration, this is the command. We say copy running configuration to startup configuration, VDC all. It copies all VDC configuration, but this can be done only from default VDC. To display all display only the default VDC configuration, this is the command from the default VDC. We say show running configuration VDC. To see all the running configuration, show running configuration VDC all. To see all the startup configuration, this is the command. Next, now there is also something called booting sequence. Because we have multiple virtual machines inside, you can have booting sequence. I want all to boot same way at a time, parallelly. Then what I can do is I can give the same boot order value. Lower the VDC with lower boot order is booted first. So when I say VDC red boot order 2, VDC green boot order 3, then red gets booted first. To reload all the VDCs, this is the command from the default VDC. To reload only one particular non-default VDC, reload VDC, VDC name. To restart, this is the number, this is the command. To suspend a particular VDC, this is the command. To resume back, put no in front of it. That will bring from suspension. So storage VDC we'll see tomorrow, same time.